Yeah, good afternoon, Messi. So what is the topic of your presentation?
Minimax search algorithm.
Yeah.
Minimax search algorithm.
Okay. We have to be we have to be a bit louder. So you have already shared a screen. Now start sharing the PPT. Yes. The Minimax search procedure and alpha beta pruning, right? So both of you are giving it separately or together only? Okay. Okay, start.
A very good afternoon to each and every one of you. Urmimala and myself will be presenting on the Minimax search procedure and alpha beta pruning. In our presentation, we shall go through the algorithm and applications of the Minimax search procedure, as well as algorithm and applications of the alpha beta pruning. Now, everything has a history, a past. In the world of AI, one particular person's creation opened the way beyond what traditional machines did. In the early 1960s, Arthur Samuel had succeeded in building the first significant operational game playing program. This playing program played checkers, and it learned from its mistake and improved its performance. Now, this is where he flipped the history. His program used the Minimax search procedure and is the first practical application. The Minimax search procedure is a depth-first, depth-limited search procedure and is used to determine the best move in a competitive environment. The final decision is based on the best possible score found in the branches. In simple, it doesn't just look at the next move, it predicts the future. It assumes the opponent will play their best, then calculates the best of worst scenarios to find the path with the highest score. The slide is not moving.
Maybe if first download and or
Now we shall go through an example. This looks complex, but it's just a war between two players, minimum and then the maximum. Minimum who wants the highest score and the maximum that wants the highest score and minimum who wants the lowest. Let's check the algorithm first and find out who wins. Algorithm. Step 1. If the maximum depth is reached or the game is over, return the static evaluation score. It has an empty path. Step 2. Create a list of all possible legal moves from the current position to explore the next level of the tree. Step 3. Set an initial best score to the minimum possible value to ensure the first explored move becomes the baseline. Step 4. For each move, call the minimax function again for the opposite player at the next depth level. Step 5. If the value returned from the move is better than the current best score, update the score and the best path. Step 6. After examining every move, return the final best score and the complete best path to the previous level. Now, keeping in mind the algorithms, we shall go through the same example and find out who really wins. Now, here the example, the red arrows is showing the maximum, checking out the possible paths, and then the gray is the minimum move. The application of minimax search procedure. It is a decision-making algorithm used primarily in two-player, turn-based games, example chess, tic-tac-toe, to determine the optimal move by maximizing gain while assuming the opponent minimizes it. It is applied in artificial intelligence for game playing, economic simulation, and robotic path planning to simulate further scenarios. Here is an example of the minimax procedure, the tic-tac-toe. Now, if you see this slide here, we can see the gameplay that is, sorry, the game that is going on. If you see, the X wins. The goal is never lose. The minimax is a decision-making algorithm for two-player games like we've already discussed before. In tic-tac-toe, it explores every possible move to ensure it always puts the most efficient path. This is a two-player game with a maximizer and then the minimizer. We will be saying the maximizer as player one and minimizer as player two. The maximizer tries to get the higher score, win equal plus 10. Now you must be all wondering why plus 10, but this plus 10 is just a standard best practice in textbooks and tutorials. It is easy to read, number for humans. Minimizer player 2 tries to get the lowest score, loss equal minus 10. This is how the algorithm works.
It is from 1 to 2 to 3, 4, 5. Means there are so many steps available, right? So min max base, we have to move on. Carry on.
This we're checking from the perspective of player X. Instead of O, we're checking for the player X. If you see the first, you see that there are four possible places where O can place its move. Then according to that, X makes its move, and then later with the position from step number 7, you can find that X will win.
Excellent. Okay.
Next, alpha beta pruning will be passed on to Umi Mala. She will be doing something. Next,
You would give a request for sharing. Yeah, you are already sharing. Like, slideshow किया second slideshow slideshow don't have the हाँ from the the last slide that as we discussed. Go on.
yeah.
One more. Yes.
Good afternoon, everyone. So today my topic is alpha beta pruning. So basically, alpha beta pruning.
You can pause that or minimize it. Just click and drag it. That one, yes. No, no. Yes. তাত ধৰি পেলাই টানি দিয়া তললৈ না সেইটো না ওপৰত এপ য'ত yes তাত ধৰা ৰ'বা এতিয়া আকৌ তালৈ আহা ইমেজ চাৰ্চ স্লাইড শ্ব'
Sir, he said. So alpha beta pruning is a modified version of the Minimax algorithm. It is an optimization technique for the Minimax algorithm. Minimax procedure is a depth first step. So alpha beta procedure एक मिनिमैक्स एल्गोरिथम का मॉडिफाइड वर्जन है जहाँ इसको हम फैक्ट ऑप्टिमाइजेशन टेक्निक भी बोलते हैं और ये मिनिमैक्स एल्गोरिथम का फास्ट वर्जन है. Here, one part is explored as far as time allows. The static evaluation function is applied to the game position at the last step. The efficiency of the depth first search can improve by branch and bound technique, in which partial solutions that clearly worse than known solutions can abandon early. So here branch and bound technique is where the algorithm split a large problem into smaller subproblems. And it is necessary to modify the branch and bound strategy to include two bounds, one for each of the players. This modified strategy is called alpha beta pruning. It requires the maintenance of the two threshold values, one representing the lower bound on the value that maximizing node may ultimately be assigned, that is called alpha, and another representing the upper bound on the value that minimizing a node may be assigned, called beta. Simply, alpha is a maximized value and beta is a minimized value. And each level must receive both the values one to use and one to pass down to the next level to use. Minimax algorithm's time complexity is high. This drawback of that algorithm overcome by alpha beta pruning. It is called alpha beta pruning because it passes two extra parameters in the minimax function named as beta alpha and beta. So here we know that alpha is a maximizer, which is the best means highest value, which is start with minus infinity, and beta is a minimizer where the initial value starts with plus infinity. The rule: if at a point alpha greater than equal to beta, we prune the remaining branches of that node because the opponent would never let us reach those states. The max player only update value of alpha and min player only update value of beta. While backtracking will be tree, the node values will be passed to upper nodes instead of values of alpha and beta. We will only pass the alpha beta values to the child nodes. Sir, can I this explain with board? Sir, last thought. त्याबाबत ॲप्लिकेशन सांग. So, application of alpha beta pruning. The logic behind alpha beta pruning is used in any scenario where we need to make an optimal decision while facing an adversary and have limited time or computing power. Here are some prominent real life applications. First one is competitive gaming like chess, Go, Seekers. This is the textbook application. AI engines like Stockfish says use alpha beta pruning to look 20 to 30 moves ahead. Cyber security and defense. In high stake security, alpha beta logic helps in risk assessment and penetrant testing. Automated logistics and supply. Large companies use search trees to decide how to route goods through a global network. Financial trading and market modeling. High frequency trading algorithms use similar pruning logic to evaluate market moves. Fifth one is medical diagnosis system. In complex diagnosis trees, doctors or AI systems use a form of pruning to eliminate possibilities. Uh, why we use alpha beta pruning? Alpha beta pruning is an optimization technique used to reduce the number of nodes evaluated by the minimax algorithm in its search tree. It is primarily used in two-player zero-sum games like chess or tic-tac-toe, where the computer needs to calculate the best possible move. The core purpose is simple efficiency. So here is a conclusion. Sir, what to use करना था? How we are calculating in alpha beta pruning? Second example. So this is alpha, beta, alpha, beta. ये लास्ट टर्म को हम टर्मिनल नोड्स बोलते हैं. So alpha beta proning में हम पहले ही बोल सकते हैं alpha beta proning में से their first starts होता है minimix algorithm की तरह. So first ये नोड यहाँ पर आएगा, then इधर आएगा, then इधर हम यहाँ से कैलकुलेट करेंगे. तो ये मिनिमम है, बीटा हमेशा मिनिमम होता है. तो ये दोनों नोड से जो सोता है वही इसका वैल्यू होगा, बीटा का वैल्यू. देन अगेन इन दोनों में से सोता है 2, तो 2 आया.
2 और 1. 2 and 1. The smallest one is
1 to 2 में जब bisa. कारण 3 ऐसे 3 के आमा होल 3 उसका से हम क्या लगे तो 1 जब हम पूर्ण करें तो मीन स्टार्टिंग पॉइंट. Then again अल्फा का मतलब मैक्स है, मैक्सिमम. तो बीटा का 3 और 2 में से जो मैक्सिमम है उसका वैल्यू 3 होगा.
correct. So we are taking actually minimum of this. Okay. So minimum value comes as 3. And here 2 and 1. Minimum value will be 1. And this is maximum. Similar.
Then again similar this process is same. 7 है और 8 से 7, 9 और 10 से 9, 7 और 9 से 9.
ठीक है, और उससे बड़ा ये है, तो जो बड़ा होने से और वो अल्फा है, अल्फा से क्या होना चाहिए हमेशा बराबर या तो बड़ा होना चाहिए. That's why we have proved that part. And in this case 9 and this bigger than 3 bigger than okay. So that's why we don't need this. So we have proved this here. क्या है मशीन ये तो आपको समझना है. Any questions? Don't answer questions from that question paper of your exam. No question. Sumi is in the online. Sumi can ask. Sumi, do you have any question? Sumi, do you have any?
Sir, actually, due to some network problem, I can understand some weak.
डर मत जाना, वो जैसे देके रखा है वहां पे. डर मत जाना, वो जैसे देके रखा है वहां पे. If you have question, ask. If you have question, ask.
That alpha beta purring part, can you explain it briefly?
to repeat the question.
क्वेश्चन फिर से रिपीट करो.
My ears. Alpha purify অকণ নুবুজিলো নেটৱৰ্ক ইছ্যুৰ কাৰণে অকণমান বুজাই দে.
DS2C. DS2C. I2G.
सुमीर चैट बॉक्स में पूछो.
Sumi, you can keep the question in the chat box also. You will find a chat there. You can leave the question there also.
Okay, sir.
Anyway, I think Sumi is having some network problem, but from my side, I have to say that slide part is very decorative and very clear. Okay, so that way actually we have to prepare the slides. Not much more text should be there, few text, but more representation, more figures. So that is fulfilled by your slide. Good. One question is what actually I want to ask, that your topic was what? Minimax. Why this term is minimax algorithm? Correct. We are maximizing, just like she said, it's a kind of competition. We are always trying to maximize our performance and minimizing the opponent's performance, right? And what do we understand by alpha beta pruning? Or we can say like that, if we don't do this pruning part, T will be growing, right? And their time complexity will be increased. So to prune out the unnecessary part, we use this alpha beta pruning, which has much lower time complexity than the min-max algorithm or minimax algorithm. Concept is clear. We use this algorithm in the game playing techniques. Okay, that's an important part of AI. Right? Clear? So this is a very good presentation. Again, one more claps for them. Thank you.